In this video, we'll be linking data to decision making. Farm data falls into two main categories, monitoring data and spatial data. Monitoring data is temporal, so it tracks conditions over time. Using sensors or meters at specific locations, it shows how things change, like soil moisture or climate, and it helps you see the impact of your decisions. But it's ultimately limited to where you place the sensor. Spatial data, on the other hand, is geographic. It's like a snapshot of the whole farm, but it's static and it doesn't track change over time. However, used together, these types of data complement each other perfectly. Monitoring data gives you the detail over time at a point, and spatial data helps you contextualize that monitoring data and understand how that point fits into the broader landscape. This video will cover different types of spatial data and monitoring data for farm water management and how you can get the best out of both. The beginning of any farm decision should start with spatial data. Having a good look and making a collection of spatial data is a really useful way to lay out all the variability you've got, and especially your variability in risk, so that you can put the right strategies forward to lower the risks to production and help you evaluate the suitability of a site so you can plant the right things in the right places. Topographic maps are a great place to start for water management. Topography means the shape of the land, and 3D digital models of topography are great for demonstrating surface flows and depressions in the paddock where water is most likely to accumulate and waterlog. Watershed maps are especially great for visualising surface water flows. These maps show natural drainage paths based on topography. You can also take topographic data a step further and model water movement too. You can mimic surface water applications and see how topography contorts the water, showing you where water is likely to pool up and accumulate. And you can even model drainage pathways before you put them in, which is especially useful for any drainage design. EM maps are a good guide for figuring out your soil types. EM maps show the electromagnetic signature of the soil at specific depths, which correlates pretty well with soil conductivity. So differences in EM can indicate differences in soil texture, which can give you a fair idea on which parts of your paddock have a greater or lesser water holding capacity. EM can also point out which areas are harbouring salinity and stoniness so that you can amend these problems or just avoid planting there. All soils have a natural infiltration rate based on the texture, so the particle size of the soil, and the soil structure, meaning the pore sizes, the gaps in between. Infiltration tests are often overlooked, but doing a few tests around your paddocks could save you a lot of time and water if it helps you design an irrigation plan or system that matches your soil so that you can avoid issues like runoff and erosion. This table on the left shows how infiltration rates of bare soil can vary greatly from 150 millimetres an hour on sands to as low as 1 millimetre an hour on some really heavy clays. This is important to know when you're thinking about what pack size to install on pivot and what tillage or ground cover might be necessary to get any water on at all. To find out your infiltration rate, you can use an infiltrometer. The image on this slide shows a mini disc infiltrometer, but you can also go as simple as a single ring or double ring infiltration test. The other half of our farm data is the monitoring side. This is the data that will guide your ongoing decision making, in particular irrigation scheduling. And when you have a good understanding of your spatial data, this can help guide you with what monitoring data you want to collect and where the best place to collect that data would be. In terms of water management, nothing is more important than a rain gauge, especially in Tasmania, where we've got dramatic topography that causes a lot of variation in weather. Weather stations outfitted with wind speed, temperature, solar radiation and humidity sensors have the ability to calculate ETO. ETO tells you how many millimetres of rainfall equivalent are being used up by your plants. So both rainfall and ET are in the same units, and this gives you a really simple way to compare the water that's going into your system and the water that's going out. The BOM also operates a freely available weather station network, and because the BOM network has been running for decades, they've got enough historical data to do some really cool calculations on rainfall probability, which can give you some good insights on whether the region is on track to be drier or wetter than the historical average, which can help give you some confidence with your decisions. Keep in mind how far away the weather station that you're looking at is, and consider looking at multiple nearby weather stations to get an idea of how much weather variability there is in the region and how relevant the weather station might be to you. A big one for water management is soil data. Soil is your reservoir, your bank for moisture, and the bucket you've got to work with. Soil moisture probes go a step further than rainfall data, showing you how much rain has actually entered your soil and if it's located in the root zone. They become a really useful guide for irrigation when you add full points and refill lines and stress lines, and the position of these lines will change depending on what you're growing and what your soil type is. Tensiometers are similarly useful, but rather than simply explaining soil moisture as a percentage, they illustrate soil moisture by the tension required to draw it up. So when there's less moisture available, more tension is needed, and conversely, a saturated soil requires very little tension. This is useful for understanding how much energy plants are exerting to siphon water, so you can identify plant stress very accurately with a tensiometer. When you're doing monitoring right, you'll only need one probe, possibly two per paddock, and even though the actual data collecting range of that soil moisture probe wouldn't be more than 10 centimetres squared out of a 30 hectare paddock, you'll be using your spatial understanding of the site and its soil and topography, giving you a solid approximation of which parts of the paddock are similar to the probe and which parts are relatively drier or wetter. And that's when that small patch of soil readings becomes essential to your understanding of the whole system. For example, I've got an EM map here and I'm placing a probe right here, and I can see that this spot has a moderate water holding capacity and a gentle slope. And let's say that the soil moisture graph here is fairly approximate to that spot there. But obviously I know that there's a large proportion of the paddock coloured red, which has a lighter soil texture and a lower water holding capacity. So knowing this, I might decide to lift up my refill line and my stress line and irrigate lower volumes more often so that my irrigation is meeting the needs of the dry spots of the paddock too. To get more comfortable using soil moisture data, a great free monitoring platform is the Farming Forecaster. The program continuously reports soil moisture and rainfall data from sites around the country to tell you what the current growing conditions are. The second part of the system is a forecaster, which models grass growth based on the current soil moisture levels and then the historical weather averages to give producers an idea of how much feed they can expect to get out of their pastures in the coming months. If you're using the website to make decisions on your farm, consider looking at the data from multiple surrounding sites. Additionally, you can click on the information panels to investigate the site a bit further and find out what their soil type is and what pasture species they're growing, so you can see how relevant their results are to you. And there's plenty of extra information and tutorials on the NRM website as well. The Land Information System Tasmania, or LISTmap, is a great place to start for spatial data. They've got hundreds of maps of the state, and I've included a few useful ones on this slide. There's salinity, erosion risk, geology, which might give you an idea on what soil types you've got, and there's ones for land capability and enterprise suitability as well. Their stuff on enterprise suitability is pretty handy for decision making. You can work with a suitability matrix, and it's an easy way to make sense of a lot of spatial data while still being objective with it. So you can narrow your search for geographic attributes to just the simple key factors. So to recap, it's worth collecting some spatial data about your farm to develop an understanding of the geography and what parts of the farm are at risk for waterlogging and drying out. In this way, spatial data helps us figure out what issues we need to monitor, and it also helps us contextualise the data from soil moisture probes so that it's relevant to the whole farm.